So I want to find the angle between these two lines. Now let's think about what all these bits of information here actually tell us about these lines L1 and L2. Well, 913 minus 3, that's how we get to the line L1. So off we go along 913 minus 3 and we're on the line. Now once we're on the line, we're off. We go as many as we like, lambda in this direction, of 1, 4, minus 2. Now, that's not written very well, but you know what I mean. 1, 4, minus 2. Okay, the blue line. So, how do we get to the line? 2 minus 1, 1. So, if this is the origin, then we head off along here. 2 minus 1, 1. That gets us to the line. And then we do any amount we like of 2, 1, 1. And that gets us in this direction, like that. 2, 1, 1. So that vector there, that vector there, that vector there, they're all 2, 1, 1. And what we want is the angle between the two lines. So let's draw out a little picture here, because we know we're going to use the dot product on these two vectors. But what are these two vectors? And this is the important bit. The vector here, this one here, is this one here. It's 1, 4, minus 2. It's the direction vector. This is the direction of L1. It's got nothing to do with how we get there. The angle there, theta, that angle between the two, if I change the 913 minus 3 to this or this or this or this, it doesn't matter. It's not changing that angle. If I change the direction of the line, then obviously this angle will change. Similarly for the blue line, not relevant, very relevant. This line here, this one here, this is the direction of L2. So the angle between two lines is actually the angle between the directions of the two lines. So let's find the angle between these two lines. So we're doing the dot product of 1, 4, minus 2, that's the direction of line 1, and 2, 1, 1, that's the direction of line 2. That will equal the length of the first vector, 1 squared plus 4 squared plus 2 squared square rooted, multiplied by the length of the second vector, 2 squared plus 1 squared plus 1 squared square rooted, multiplied by the cosine of the angle between them. Okay, dot product, we do this times this, plus this times this, plus this times this, and that's the left-hand side. So that will be 2 plus 4 minus 2, and that's going to equal 16, 20, root 21, root 456 cos theta, giving us cos theta is 4 over root 21 root 6. Now, how do we know, because I just drew this picture randomly, how do we know that we've found the acute angle? Is this the acute angle? Well, obviously I could do shift cos, couldn't I, and find out. But I might have found the obtuse angle between the two lines. And the way to find out which one you've got is to just think about a cosine graph. Now, acute angles between two vectors are represent this part of the graph here, between 0 and 90. So the cosine will always be positive, and this cosine is positive, so this angle is going to come out to be acute. If I'd accidentally found this one, the obtuse angle, that would be something between 90 and 180, so the cosine would come out negative, and I would be able to just see that it was negative just by looking at it. And by getting rid of the negative sign, and then doing the inverse cosine, I'd get the acute angle. So, what do you need to know? Well, you need to know the formula for the dot product. A dot B is mod A, mod B, cos theta, but as always with the dot product, what's important is what is your A and what is your B. They both come from a central point, and in the case of an angle between two lines, one of them is the direction of line 1, and the other one is the direction of line 2. And that's what goes into your B is direction of line 2, and your A is the direction of line 1. If cosine theta comes out as positive, that means that you are in this section of the graph, of the cosine graph, which means you've got the acute angle, that's what you found. If your cos theta comes out to be negative, then you're in this part of the cosine graph here, this bit, and your angle is obtuse. That's the other angle between the two lines, this one here. So just check which one you're after, the acute or the obtuse.